This video is regarding the CPA, or the gas analysis part of your exams and your assessment. Before we start, a very quick word of advice to you. You must be able to understand figures which come after the decimal point. 9 out of 10 students that fail this exercise do so not because they're not carrying out the exercise properly, they are, but they can't understand the readings that come out of the machine, and it's always because they can't understand what's going on after a decimal point. There are lots of good videos on YouTube regarding this. If you don't understand them, please go and watch the videos. They're very good and you'll understand them by the time you finish the videos. So enough of that, let's get on to the gas part. Before you use your analyzer, it's essential that you are familiar with it and that you carry out the following checks. Make sure the batteries are in correctly, that they're charged up, and that they're not leaking. Make sure the analyzer has a current calibration certificate. Usually these last for 12 months. Make sure that the display is readable and is reading correctly. And remember to purge the analyzer, usually in fresh air, but according to the manufacturer's instructions. Make sure the pump's working. You'll be able to hear that during the purge. You can hear the pump working. Make sure the filters and the traps are clean and dry, and that the tubing to the probes hasn't got any leaks or cracks in it, or any damage that would mean your readings would be affected. There are two parts to the CPA guidance. The first one is the investigation of a report of fumes. This is when somebody phones you up as a gas engineer and says, I can smell fumes in my house. Or when a carbon monoxide alarm has gone off and they phone you up and say, my alarm's gone off and I can smell something funny, or something similar to that. The other side to it is testing appliances to see whether they're working correctly. So let's first go to the investigating of a report of fumes. It's not something you can learn per se and remember. What you do is you use a flow chart, and all of your books will have this flow chart in them. It's a standard chart, and you simply work your way from the top of the chart. You ask the question and then you move on to the next box. So for example, it says here the gas operative arrives at the property and has an initial discussion with the customer. You've got to talk to the customer to see what's going on. And then you move down and the next box says, is the problem present now? Well, if it is, you go straight down to where it says note appliance in operation and check for the presence of carbon monoxide using the approved methods. If the problem's not present, then you follow the other route, which takes you to a box which says more detailed discussion with the customer to find out when the problem occurs and which appliances are in operation when it does occur. So you can see this is simply a flow chart. You ask the question. If the answer is yes, you follow one arrow. If the answer is no, you follow the other arrow. Very simple. In your assessment, if you're asked to do this, or if in your exam there's a question about this, just follow the flow chart. It will give you the answer. So when you've got there and you need to carry out your initial carbon monoxide test, you close all the external doors, windows, and what ventilation you can, and you record the level of carbon monoxide over a 15-minute period. If the indoor level of carbon monoxide starts to rise during this period, check for carbon monoxide migration from other sources. It might be that there's a very busy road outside and the vehicles passing, heavy lorries. If there's a traffic jam and the cars and lorries are sitting still, they might be producing enough carbon monoxide to affect what's going on indoors in your house. That's just one example of migrating from other sources. If there's no rise over the 15-minute period, proceed to the appropriate test in the general testing procedures. Sometimes it's useful to check to see whether products of combustion are present in a room. Not only carbon monoxide, but products of combustion, which will tell you that an appliance is leaking products of combustion into the room. And you can do that by checking the amount of carbon dioxide. All of the gas analyzers can do both these things, carbon monoxide and carbon dioxide testing. And you check for carbon dioxide because the appliance itself might not be producing carbon monoxide. So you would get a negative reading for carbon monoxide, but you could still have the appliance spilling products of combustion into the room. If you check for carbon dioxide, it will let you know whether an appliance is putting its products of combustion into the room. And remember that products of combustion move around the house. They go from room to room on air currents and heat currents. So it might be you're getting a reading in one room, but the problem's actually in a different room entirely. It's just the way the house is made and the currents going through it are giving you a false reading in a different room. Now with cookers, they can produce concentrations of carbon monoxide in excess of 30 parts per million for short periods of time. And in particular, the grills. Now we'll come on to grills later on because they are, of all the appliances you're going to deal with, they are the ones that are most likely to cause problems with your gas analysis. These high concentrations are allowed as long as they do not last longer than 20 minutes. This particular rule is well worth remembering for your exams and your assessment. The cooker allowance. Right? They're allowed 30 parts per million for up to 20 minutes. Once you've carried out your fume investigation for good or for bad, you've got to fill in the appropriate forms and send them away to be logged and registered. So let's move to testing appliances. You will definitely be asked to do this in your assessment, and you will be asked exam questions around this as well. When you go to test an appliance, you warm the appliance up for 10 minutes. Appliances are always tested at full rate. They're tested when they're going as hard as they can. So this means that if you're dealing with a range rated appliance, an appliance that tells you it goes between, let's say, 15 and 25 kilowatts, depending on how you set it, then you turn it up to 20 kilowatts, test it, and then you put it back to however many kilowatts it was set at when you found it, and you test it again. So on a range rated appliance, you do 2 tests, one at full rate and one at the rate that you found it at. Definitely remember that for your assessment. Now there are set action levels or trigger levels for what you're measuring, and you're measuring the ratio between carbon monoxide and carbon dioxide. You're checking that ratio. So different appliances have got a different figure that they trigger an investigation at. So for example, a central heating boiler, if you get a ratio of higher than 0.008, then you have to do some remedial work. There is something wrong with the appliance. If it's under 0.008, then it's fine, it's passed the test. If you go down the list just a little bit further, a flueless cabinet heater, LPG, just using an example, is 0.004. If it's above that, it's failed. If it's below that, it's passed. What I'd like you to remember, and like I say, this is in all your books, so you just look at the chart and you see whether your appliance has passed or failed. But please remember, with cooker grills, there are 2 action levels or trigger points. If the grill has got a CE marking, something that looks like that, then the trigger is 0.01. If it's above 0.01, then it's unsafe. If it's below 0.01, it's fine. If it hasn't got a CE mark, so you're going to have to look and find if it's got a CE mark, or they will show you it in the manufacturer's instructions. If it's not got a CE mark, then the action level is 0.02. So please be aware of that, again, for your assessment. Make sure whether your cooker has got a CE mark or not. So what causes high ratio readings? Well, misuse, lack of maintenance, which is the one you're going to come across most often, and that's caused by dirty cooker grill frets. Cookers get very dirty. They get grease and oil and water and bits of food all over them. They're your most likely candidates for bad ratio performance. Or the other one is misplaced coal on fuel effect fires. Fuel effect fires very often have a sequence that you must put the coal in. If you put it in a different sequence, and again manufacturer instructions will show you this, then you'll get an incorrect reading, and you'll probably get a high reading. Now have a think about it. If you were an assessor and you had a fuel effect fire in your assessment area, it would be the easiest thing in the world just to put the coal in the wrong place, in the wrong order, in order to test your students' accuracy. Bear these little things in mind. Another cause could be damage, and another cause could be that the appliance is simply old and everything's starting to get worn out. Now the sampling probes you use, boilers use what they call the standard sampling probe. It looks like this. It's got that cone on the end, and that is your boiler sampling probe. Cookers, flueless water heaters, and flueless fires use angled sampling probes. These probes have got little holes in the end of them, or along the top of them. Make sure the holes are pointing downwards into the flow. So the products of combustion will generally be coming up out through what is basically a very short flue. Make sure the holes are pointing into the flow of the products of combustion. So the next question is, where do you sample? Manufacturer's instructions will show you where to take your samples from. This is usually in the MIs under the section called commissioning, because carrying out these tests is part of installation and commissioning, not only servicing. Here's a photograph of a boiler being sampled, and the sampling probe is going into the flue via a specially made socket. Here's another example. This is an open flued appliance, and the manufacturer's instructions have told you to slide the side out and stick the probe into the products of combustion that way. Another example, again, the manufacturer instructions would have instructed that this is how you do it for this particular appliance. Now, what throws a lot of people out is what happens with an open fluid gas fire that's attached to the wall. As you can see from this picture, an open-ended sampling probe is needed. However, in pretty well 99 out of 100 cases, there is no way to get the probe into the chimney without taking the fire off the wall. So the rules state that if you cannot put the probe into position without removing the fire, then just don't carry the test out. If you get presented with a fire in your assessment and you're asked to carry out a test on it, and you can't get the probe into the chimney without removing the fire, you simply don't carry out the test. It's a good one for assessments, this, because it makes you have to move to a different method of ensuring that it's safe. And a different method is that you check all the disturbed gas connections, test for tightness, which you will already have done, confirm that the burner operating pressure and gas rates are correct, and then that you'll check the operation of the FSD. You'll ensure all the seals and fastenings are present, in good condition and secured. If you can, you carry out a spillage test, and you ensure that all the warning labels are present. These are the checks you must carry out if you cannot get the probe into the chimney of a gas fire or any other appliance, but a gas fire is the one where it's going to become obvious to you. Then you must carry out these checks as an alternative. Now, if a new component, a new part has been fitted, or you've fitted a new part, or the assessor has put a new part in to an appliance you're testing, that part will probably have been covered in a protective film to stop it rusting or corroding or being damaged while it's sitting around on their shelf. When you light the appliance, the heat will start to burn off that protective coating. And the fumes that come off the burning protective coating will often affect your CPA readings. We're aware of that, or the people that make the rules around gas are aware of that because it's happened. And they say that to avoid this problem, we're allowed to sample appliances where new components have been fitted, and only in that case, where new components have been fitted, we can sample them at 20-minute intervals. So that's sample them every 20 minutes until you reach a satisfactory reading. So you've put something new in, you fired it up, you do your reading, and your reading's way out. You're allowed then to wait for 20 minutes and then do it again. If the reading's still out, you can wait 20 minutes and do it again until the reading normalizes. And please remember, you can only do that where a new component has been fitted. And what effect does it all have on the unsafe situations? Well, if it's a flueless appliance and it fails the ratio test, it's regarded as immediately dangerous. Flueless, immediately dangerous. If it's an open flued or room sealed appliance and it fails the ratio test, then it's at risk. Flueless ID, open fluid or room sealed, at risk. Now I said I was going to speak about grills. So we'll quickly cover them. Overhead grills, these are the grills that sit above the hobs. Overhead grills are subject to a huge amount of combustion stress. They must be shown to be able to operate safely in the worst case scenario. I'm sure you've heard those words more than once. Remember that if the hob burners are on, then the air that the grill above it has access to has already been burned, and it's had the oxygen removed from it. So already it's struggling because the air that's around it no longer has any oxygen in it. In addition to that, the deoxygenated air, they also have to cope with steam and grease and goodness knows what else going up into them if you're doing something on the hob itself. So in your assessment, when you carry out a check on these grills, you must have at least one pot, preferably two. If you can, always use two, of boiling water on the hob. So you put the pans on the hob, you heat them up, you get them boiling, then you do your test. Then you do your test. Some schools say that any reading of any appliance, as long as it's below 0.004, is fine, and anything above 0.004 fails. It makes it a lot easier for you as students, but in reality there are rules around this. That only applies if the appliance has a CE certification, like we spoke about before, or a GC number on their data badge, and the appliance must be one of the following: an open fluid or room sealed boiler, a warm air heater, a water heater or circulator, or a room sealed convector heater or fire. So that applies, but it only applies in those circumstances. It's acceptable to use the initial as found. That means as you found it when you first started working on it, of 0.004 to determine whether a full strip and clean service is required. A reading in the case of what I explained to you, the CE certificate and the types of appliance, a reading of 0.004 or less does not require a full strip and clean service, although you must carry out the essential safety checks on the appliance itself. I hope that this has helped you, and good luck with your exams and your assessment.